everybody. I'm Sharon Gratch. I'm a senior software engineer at oVirt team Red Hat. And today I will talk about high-performance virtual machines, which is a feature recently added to oVirt 4.2 and was enhanced in oVirt 4.3, which is the coming oVirt version. Now let's start by understanding what is a high-performance VM. So high-performance VM is actually running a VM with the highest possible performance and with performance metrics as close to bare metal as possible. But when we are talking about high-performance VM, we are not talking about real-time VM, and it's important to emphasize that because we are not supporting real-time, and sometimes people getting confused between high performance and real-time. So when we are talking about high performance, we are talking about the amount of operations that can be done in a given amount of time, and of course we want a higher amount of operation, as much as we can. When we are talking about real-time, we are talking more about a predictive issue. We're talking about predicting that a set of operations will be able to be completed successfully with a result in a given amount of time. So real-time doesn't necessarily deal with high performance. It's two different things, and we are not supporting real-time for now anyway, only high performance. So that's a high-performance VM. Another thing that I want to emphasize is that in today's presentation, I won't show no numbers and no graphs because showing the performance improvements is a bit tricky, because to show that the VM performance was improved, it depends on a lot of things, either on the VM itself and on the host that the VM is running on. It depends on the settings, it depends on the load, on the memory usage, etc. So instead of showing you graphs of how performance improved, I will just stay on describing the new feature, what we did, and how we simplified things in this feature. So why we added this feature? Why support high-performance VM? Why we needed that? So first of all, application requirements. There are few applications that require better performance than others. For example, and this example is taken from oVirt actually, SAP HANA. SAP HANA is an in-memory database management system that processing a huge amount of data in a short amount of time. And SAP HANA could not run on our VMs, only on bare metal machines. And they asked us to implement some kind of easy way to create high-performance VMs so that they can run on oVirt machines, on oVirt VMs. So it's just an example, but there are other applications like that. Another reason for this feature is that actually users could take the old VMs, even before this feature, and tune the VMs so that the performance will be better. They just needed to go over the VM settings one by one, understand what they are doing, search for the relevant settings, and improve the performance. But it was not a straightforward mission to do. And now it's much more easier. Another thing is live migration. Live migration is a very important ability for VMs. Live migration means that a running VM can switch to run on another host if required in a minimal downtime. And live migration was not supported for such high-performance VMs before, and now it is supported. And last reason for implementing this feature in oVirt was that there was a lot of missing functionality. And we implemented a lot of additional functionality now for improving the VM performance. For example, we added support for headless VMs, we added support for huge pages, for pinning IO and emulator threads, and for multi-queues per virtual interface for networking, etc. Now, when you create a VM in oVirt, you need to give the name of the VM and other settings, and one of the settings that you also need to give is the VM type. It's called optimized for. And the reason for this field is to know how this VM should be used. Should it be used as a server machine or as a desktop machine? And upon this feature, we will know how to optimize the VM, which devices should we remove, how we should set that. So we use that field, the optimized for field, and added a third value called high performance. And now, when you have an application like SAP HANA that requires high performance, like the yellow application here, then we ask the user to set the VM type as high performance, and then automatically the VM will be high performance VM. This is how it is shown in oVirt UI. This is the UI for editing or creating a virtual machine. So you can see there is the optimized for field, and there are 3 values, server, desktop, and now the new value, high performance. And once you set this value, you will get a high performance VM. So it looks very easy. It is easy, much more easy than before, but not that easy, because by choosing this new high performance VM type, actually behind the scenes, 2 things happen. One, automatic settings. The VM will be, as I said, pre-configured automatically with a set of configuration settings, recommended settings, so that the performance will be higher. But in addition to that, there are a set of few settings that cannot be done automatically, because it's very hard for us to calculate in advance what will be the host that the VM is running on and exactly what should be tuned on that VM. So there will be still a list of short manual settings that the user will be recommended and asked to set. But we will help him to do that and check if it is already set or not. It will be much easier for him to understand what he should do. And I will show everything later on. 2 things to emphasize about that is, one, nothing is mandatory. All the automatic and manual settings are non-mandatory. The user can choose if he wants to set all of them, none of them, part of them, depends on what he wants to do. And another thing is that you can do that for a new VM or existing VM. You can take a server VM and switch it to be high performance just by changing the VM type and setting the manual settings. Now, you can ask me the following question. If it's so easy now to create a high performance VM, just choosing the high performance VM type and then setting few manual settings, and by creating a high performance VM type, I get a VM with the highest possible performance, as close to bare metal actually. So why not creating all VMs as high performance VMs? Sounds reasonable, right? So the answer for that is that, as everything in life, everything good in life, there is a price for that. And the price for the high performance VMs is flexibility. So there is a balance between performance and flexibility. The higher the performance will be for the VM, usually the less virtualization flexibility you will have. For example, when you create a high performance VM, automatically you will not get a graphic console. You will not get a USB device. The list of hosts that the VM will be able to run on is limited, more limited than a server VM, etc. So there is a price to pay, and you need to understand that and balance between those 2, according to what you need. Now let's drill down to talk about the list of automatic settings for those VMs, for the high-performance VMs. So everything I will say now is automatically set for you and will increase the VM performance, should increase the VM performance. So in the console area, we are talking about enable headless mode. And in addition to that, enable serial console. Headless mode means that there is no graphic consoles at all, but you still have the serial console to manage the VM from remote, if you need to. Regarding the VM devices, this is the list of all the VM devices that will be disabled. I'm not going over them, you can read them now, but this will be automatically disabled for you by default. No USB, etc. Regarding networking, we will enable the multi-queues per virtual interface. That means that if you need to serve multiple networking requests, you will have multiple queues for that. Everything will be handled in parallel, which is great. But you need to keep in mind that for managing each one of those multiple queues, there is a thread, a virtual thread. And this virtual thread is served as for managing this queue instead of serving for processing, meaning instead of serving as a virtual CPU. So if you know you have a VM that's running with a networking load, then please stay with the recommended settings. But if you know that you won't have a lot of networking load, but on the other end, you need a lot of processing load, so you will be able to disable that. Now, regarding entropy, we will enable the random number generator to prevent entropy starvation. The same entropy as the same random number generator as done in the host itself. And regarding CPU, we will set the CPU cache layer 3, in addition to layer 1 and layer 2. I'm continuing with the automatic settings. So regarding storage and I/O, the disk interface by default is set to SCSI. The storage allocation for disks is clone or pre-allocated, so that read-write operations will be much quicker. And we enable the I/O threads, while the default we choose is 1, meaning that there will be one thread dedicated to serve for I/O requests. Now, regarding the host pinning, we will do two things automatically. First, enable the pass-through host CPU, meaning that the CPU model and the CPU flags used by the host will be identical, the same as the ones used by the VM itself. No layers in between. That's why everything will be much higher, performance higher. And another thing is we will set the IO and emulator thread pinning topology. Those two things, everything regarding pinning will increase performance much higher than other things. So those two things have a big influence on performance once you set them. And the last bullet in automatic setting is live migration. That means that we will enable live migration. And this doesn't have anything to do with performance, but we still need that because we want live migration, as we talked about it before. Now I want to talk a bit about migration. So when a high-performance VM is migrated from one host to another, the performance may be decreased because you move from one host to another, and you don't know if the destination host has the same settings as the source host. Therefore, we chosen so that the default mode for migration will be manual and not automatic, meaning that we want the user to control the migration. So for high-performance VM, the migration will be manual. The user needs to trigger that, although automatic migration is still supported. Another thing is choosing the destination host. Source and destination host should not be identical. We don't require that. If they are identical, that's great. That means that no performance decreasing will be done. But they don't have to be identical. What they do have to be is they should be compatible, because otherwise the VM won't be able to run on the destination host once the migration is done. And they should be compatible in everything, in the CPU, in the memory, in the huge pages, on all the host settings. Now, because they should be compatible, the list of hosts that can be supported as a destination host for the VM is limited. There is a subset of cluster hosts in comparing to a regular server VM, for example. And another thing to consider is that not all those hosts that are compatible and the VM can run on will supply the same level of performance results, because it depends on the load that the hosts have on that moment, the free memory that is left on those hosts. So what we recommend you to do is let oVirt choose the destination host for you. Not choose it manually. You can choose it manually, but the default is to let oVirt, you will do the manual migration and let oVirt choose the destination host, because you can calculate all the details and all the parameters together and choose the best one, the best host for running the VM. Now let's talk about manual settings. So there are actually 4 manual settings that we ask you to do. The first one is CPU pinning. Set the CPU pinning. CPU pinning means that each virtual CPU is pinned to a physical CPU in the host. The next one is declare virtual NUMA nodes and set the NUMA pinning topology. NUMA node means that the processing units, the CPUs, are closer to the chunk of memories that they are used. That is a NUMA. And of course, that if you do that, the processing is quicker. Now, we don't just say, please declare virtual NUMA nodes on your VM. We also say, pin the virtual NUMA nodes to the physical NUMA nodes on the host. And that way, you will run as close as you can to the bare metal machine, because there is no layers of translation in between. That's the second thing that we ask the user to do manually. The third one is huge pages. As you know, memory divided to pages. The pages should be managed and in a table, TLB table. As large as the table is, the more processing you need in order to manage that. So we recommend to declare pages with the highest size that you can, huge. If you declare huge pages, the result is that there will be less pages to manage. Less pages to manage, then performance will increase because the TLB table size will be smaller. And the last bullet is disable the KSM, the kernel same page merging. This is a kernel same merge merging means that you share the same pages from among, if they are identical, among all the VMs and use only one copy of them. Of course that we don't want that because once they are changed, you need to manipulate a change and create copies and the deltas and everything, and it should take time. So we disable that. I want to emphasize that the first three, CPU pinning, NUMA, and memory, and huge pages, memory backing with huge pages, have the biggest influence on performance among all others. So although they are manual, we really recommend to set them. Now, a few sentences about huge pages. First of all, as I said, we need to declare the huge pages size as bigger as we can. But of course, it depends on the pages size that the host supports. So if the host supports few pages sizes, then we'll choose the biggest one. But we should consider the free huge pages that is left on the host. I mean, if there are few sizes, but I need amount of huge pages for the VM to run with, then I'll choose the one that have the most number of free huge pages that I can use. And another thing that huge pages are pre-allocated when the VM starts to run and not dynamically. That's the default mode that we choose anyway. Now I want to drill down a bit to the pinning issues that we described before. We talked about the manual, we talked about the automatic. Now let's drill to the pinning issue. I mentioned before that we automatically set the IO and emulator threads pinning. So the algorithm that we choose for that is that we look on all the physical NUMA nodes in the host. We'll take one NUMA node, choose the first two physical CPUs. Usually it will be 0 and 1, but not always, and pin the IO and emulator threads to those two physical CPUs. If VM spans more than one NUMA node, it can be if the VM is larger, then I will take only one NUMA node, physical NUMA node, and pin my IO and emulator thread to that NUMA node, and all others will be used for virtual CPU pinning. So I won't take two from any one of those NUMA nodes, we'll choose only one. Now let's see everything in a graphic use case so that it will be easier. So here I have a host with two NUMA nodes, NUMA node 0 and NUMA node 1. Each one of the NUMA nodes is set with the memory size and the CPUs. And here is my high performance VM, which has two virtual NUMA nodes, virtual NUMA node 0, virtual NUMA node 1, with this, again, memory and CPUs. And I also enable an IO and emulator thread, as we said before that we should do. And now I want to start the pinning. So let's start by pinning the manual pinning. So let's start by pinning the virtual NUMA nodes to the physical NUMA nodes that we said we want to do. So I have two options to do that. I can pin virtual NUMA node 0 to NUMA node 1, or virtual NUMA node 0 to NUMA node 0 in the host. So of course, the option that I will choose is pinning virtual NUMA node 0 to physical NUMA node 0, because each virtual NUMA node should be at least contained in the physical NUMA node, if not identical. And if I use the other way around, then I will have three virtual CPUs in my virtual machine, while in the host I have only two, if I do virtual NUMA node 0 to NUMA node 1. So that is the pinning that I will use for my virtual NUMA nodes. And after that, when I complete doing that manually, by using the oVirt UI, I will start pinning the virtual machines, the threads, the virtual threads. So the way I will choose to do that is like that. As you can see, the pink arrows are for pinning the virtual CPUs to the physical CPUs, 0 to 2, 1 to 3, etc. And we keep on the logic that no cross NUMA node pinning is done. Because if I will pin virtual CPU 0 to physical CPU 5, then I will pin for a NUMA node that the virtual NUMA node is not pinned to. So there will be cross NUMA nodes, and the whole idea of performance will be lost here. So every virtual CPU should be pinned inside the virtual NUMA node that I'm pinning the NUMA node to. And another thing to mention here is that 0 and 1, the physical CPU 0 and 1, are left for the IO+Emulator pinning. So I won't pin my virtual CPU to 0 and 1 because that's why the physical CPUs will use for both virtual CPUs and IO+Emulator, which is not the case. So I'm leaving them only for that, and that the blue line is done automatically. So that's regarding pinning, all the pinning together. Now, future improvements. So first of all, we want to improve and change all the automatic pinning to be, all the manual pinning, sorry, to be calculated automatically. So we want to set the virtual CPU pinning and the virtual NUMA pinning automatically, and we want to calculate and set the virtual huge pages automatically. That's what we want to do in next releases. An additional thing we want to do is set affinity rules management for managing groups of high-performance VMs and hosts. And last thing is, of course, continue tuning the high-performance VM solution according to future benchmarks, because we always found more things to improve on that area. And that's all for me, from my side. I will be glad to hear questions if there are any. Yes.
You mentioned that you are using VirtIO SCSI for the high-performance gas.
Mm-hmm.
Why not VirtIO block? I've heard that VirtIO block is a little bit faster sometimes.
So it depends on a lot of things. Okay, he asked why we choose a SCSI controller for the disks and not blocker.
VirtIO block.
And not block. Because again, it depends on a lot of things, but we checked that with IO thread enabled and saw that in most cases, SCSI is quicker. But it's not, it depends on a lot of things. So again, it depends on, you do your test and see that for your specific case, it's not.
Do you, regarding the CPU pinning, do you have configured the VM in a way that you're focusing on hyper-threading CPUs? So did you disable hyper-threading on those systems, or did you configure the VM to have hyper-threaded enabled within the VM and pin those cores to the hyper-threaded cores on the host system?
Yeah, can you repeat the question again, because I'm not sure I understand.
With your CPUs, you usually have hyper-threading, and in our case, we have enabled hyper-threading and configured our VMs in a way that they also have hyper-threading in the VM.
Okay.
And we try to pin those hyper-threaded cores, the virtual hyper-threaded core, to the real hyper-threaded core. But this is not that easy, and I wanted to know how you manage those stuff, or if you just disable hyper-threading at all.
We are not disabling hyper-threaded, but okay, he asked if we use hyper-threading and how we pin the virtual CPUs to the physical CPUs in the host. So we are using a layer called libvirt for that. And libvirt does that for us, so it's pretty transparent for us. We just ask libvirt, please pin that virtual CPU to that physical CPU, and libvirt does everything behind and see if it's possible, set everything. So it's much more easier for us because we have that layer that translates it. But I hope I answered the question.
One more.
One more? Yes.
Perhaps a silly question, but is there a command line interface to ask, please optimize stuff?
Yes, we have.
What it is?
Yes, we have the REST API. As for everything in oVirt, we can do it via UI. Okay, he asked if we have a command line for doing that, or you need to use the UI, right? So we have the UI, and we also have a REST API for doing everything in oVirt. In addition to that,
What is the name of the command line? Can you write on the board what is the name of the...
I don't remember it now. It's something like create VM or add VM, but the main issue is that we use an existing command line. It's not a command line, it's more a script that you need to create using Java or Python or whatever. Yeah, and we didn't add the new, we just added the new type. So you use, you need to see how you use REST API for all other things, and just add a parameter saying the type is high performance. That's all. No time for more questions. Thank you.